precast concrete is a form of concrete that is
Then they will pour the concrete inside the mold.
Because precast receive a strength test during quality control.
Precast concrete contributes to grid building practice.
Woods are oftenly used.
Assalamualaikum and a very good evening to my beloved lecturer Dr. Rukaya and my beloved friends. Today I would like to present about the introduction to prestressed and precast. My name is Muhammad Shakif Hazin bin Kamar. So, what is the prestressed? Prestressed is the process by which a concrete element is compressed, generally by steel wires or strands. In the term of prestressed concrete, it a structural material allows the predetermined engineering stress to be placed in a member to counteract the stress that occur when they are subject to loading. Figure below shows about the loads have been applied to the prestressed concrete, which is the loads being applied on the concrete for the prestressed concrete method. It is shown the reaction of the concrete without a load and with a load. Okay, next is precast. What is precast? Precast is an object or material especially for the concrete having been cast in its final shape before positioning, which is the concrete was being mixed and cast in the factory by in its own mold and size before it's been transported to the site to be constructed. In the term of precast concrete, is a form of concrete that is prepared, cast and cured off-site. Usually, the mix of the concrete design was be controlled by the factory environment using the reusable mold. So the mold that be used can be used many times to casting the same size and the different mix of the concrete. According to the client want to choose what is grade concrete that they need to be cast. So basically, the precast concrete element can be joined to the other element to form a complete structure, which is such as the wall panel. The wall panel was been casting by each panel. So when the panel was be combined with its joint, which is male female, so the joint will be construct to form the new building such as house, a factory that use the method of the IBS method. Next is the U-trunk for the LRT, for the flyover. So the U-trunk was being cast in the factory and will be transported to the site to be constructed, to be joined with the another part to become a way for the LRT or the road for the flyover at the expressway or highway. Besides, the beam also right now has been chosen for the precast concrete, which is the beam will be constructed, will be cast by the grade that the client wants. So the method that have been construct for the beam is like a Lego method. So they will be lock the beam with its own lock to form a new beam for the structure. Besides, the culvert also was being cast in the factory and will be categorized as a precast concrete. So this method was being used to be chosen for the to prevent from the problem to prevent the problem was being occur at the site, especially when the construction involving with the river or the drainage. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqmal Aizat bin Muhammad Azmi, and I'm going to present about the question 2, which is the pre-stress construction work. Okay, so there will be a video and I will explain while we're watching the video. So as we can see here, First, they will place the bed or the mold. So there are various sizes and different type of structure that they can do by according to their standard. And then they will place the pre-stressing wire inside the mold. After that, they will place the anchor at the end of the pre-stressing wire. Then they will stretch the wire so that the stress level of the wire will increase. And then they will pour the concrete inside the mold. After that, they will wait until the concrete will dry. Okay, so after the concrete dry, then they will cut at the end of the wire so that they can take only one of the structure here. So they will take one and then do the test. If it passed, then it can be transported to the construction site to be used to construct the building. Okay, that's it for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nasha Faina bint Abdul Qadir. I will presenting the comparison between precast and cast in situ. Why precast concrete is preferred compared to the conventional in situ construction method. There are different characteristics between precast concrete and conventional in situ construction. First, we will look for the quality control. Quality control in precast concrete. Control environment prevents any outside variable. All concrete must pass strict testing. Other conditions are maintained. Because precast concrete is mixed, poured and cured in a factory, either condition and exacting measurement can be maintained throughout the process. Unfortunately, compared to the conventional in situ construction, concrete is subject to outside variable and changing condition. All testing must be performed on site. The logistics of site casting make this far more challenging. You are subject to humidity and temperature of the day you are doing the casting. You have to do the work using far less precise tools. The result is an inferior quality product even under the most ideal conditions. Next, we will look for the labor efficiency. Precast is much more labor efficient because work is done in a factory. The effort is maximized through the use of tools and machinery that simply is not available on the job site. Therefore, with the site casting, what might be done with machine has to be instead performed by hand. This is much more labor intensive, thus increasing labor costs and making the process more costly. Additionally, because machines are not involved, the labor needed for on-site casting needs to be skilled rather than unskilled. Thus, not only are more labor hours required, but those labor hours are more costly. Next, we will look for the curing conditions. Because curing condition can be controlled in a factory, they can be accelerated without sacrificing strength or quality. This simply is not the case on site. While you can do certain things to accelerate curing on site, they are difficult and generally not worth the logical hassle and cost. Furthermore, they run the risk of lower quality concrete as delicate variables are hard to account for. If you need to accelerate curing, precast is the only way to move forward confidently. Then next we will go to the fully strength. Because concrete gains strength over time, it is not fully strong immediately after drying. However, with precast concrete, the hardening process takes place before arriving on the job site. That's not the case with the site cast concrete. Before you can rise the concrete into a place, you have to wait for the site cast concrete to harden fully. This can delay the construction and increase costs. It is much more time and cost efficient to have fully hardened concrete slabs ready to be placed at the moment they arrive. Furthermore, because precast receive a strength test during quality control inspection in the factory, you do not need to conduct strength tests on the site. Strength tests are extremely critical for ensuring that your building is safe. So if you are doing on-site casting, then this is a step that you cannot be skipped. Again, because this process is outsourced to the factory with precast concrete, your job site will be much more time and cost efficient. Then next we go to the cast ahead of time. With precast concrete, you can do the casting of your material ahead of time, holding them until they are needed. Unfortunately, overlapping tasks and improving efficiency is all about impossible with site cast concrete because of the amount of space and labor required for on-site casting. You generally have to start construction while you wait for your materials to be ready. This is costly way to stand around and wait. Then next we will go for the weather. Weather in a precast concrete. An unexpected rainstorm can break construction work to a halt or if it is occur when you are doing the site casting. This is not a problem when it comes to a precast this is not a problem when it comes to a precast solution. If it is raining when your precast slabs arrive on site, you can leave them into place just as you would during a sunny day. Then for the last characteristic is specialized reinforcement. Just as a specialized insulation can be added to a precast concrete, specialized structural reinforcement can be added as well. For certain project, this is critical as it allows the panel to bear loads at a thickness that simply is not possible with traditional pour concrete. By decreasing the amount of material needed to make a building structural sound, you are saving money while being less taxing on the source available. Furthermore, specialized high-strength concrete requires exacting conditions for both mixing and curing. This condition cannot be controlled on site. However, because factory construction allow for heightened environmental control, you can use specially high-strength concrete for your construction. This allows you to create an architectural design that cannot be achieved by any other way. Then, I think that's all for me for the comparison between precast concrete and in situ cast. So, thank you.
Assalamualaikum and a very good morning to Dr. Kaya. My name is Amira bin Fatimah. So, I would like to continue for the part 4, which is how precast concrete can contribute in order to reduce the carbon dioxide and the global warming. Before I go to, so for my first point is precast concrete is durable. So before I go to about the durable, let me explain what is the meaning of durable. So for the Cambridge Dictionary state that it's endure for so long as to seem fixed or established in general. It is able to exist for a long time without significant deterioration in quality or value. A durable suitcase also designed to be a durable good. In engineering terms, it states that the ability of concrete to resist weathering action, chemical attack, and abrasion while maintaining its desired engineering properties. What makes it so durable? So, the primary ingredients of concrete, sand, and gravel, and also the cement are mineral-based. When mixed with water, the cement molecules chemically combine with the water to create a crystalline matrix of high corrosive strength. This matrix binds the sand and gravel together, creating what is sometimes known as a liquid stone. Unlike other construction materials which rust, corrode, or otherwise degrade when in the presence of moisture, concrete gets stronger. Precast concrete is extremely durable. So, precast concrete contributes to green building practice in significant ways. Its inherent strength, which is 35 to 50 MPa, which means that precast concrete is extremely durable. Because it mass can shift heating and cooling loads to help reduce mechanical system requirements. So because it is a factory made, it gives a lot of good effects in order to reduce the carbon dioxide and global warming. So, the precast concrete can reduce construction waste both in the factory and the job site. It also can reduce the mining activities and the deforestation, and it also does not add to construction indoor quality AIQ concern. The low capacity and long spans of precast members help eliminate redundant structures, and precast readily accommodates recycled content. So for the second point, we'll continue by Diana Madina, and that's all from me. Thank you.
Thank you, Amira. My name is Diana, and I will be presenting the second point of the contribution of precast concrete towards the carbon dioxide and global warming. So firstly, the concentration of greenhouse gases in the atmosphere is increasing as we speak. And according to the IPCC, the planet is heating up. So since the year 2000, sustainable building or constructions are being practiced to reduce the carbon dioxide emissions and also the heat produced from the economic activity. So when precast was introduced, it has bring a lot of benefits to the environment, and this is because that precast concrete is energy efficient. What is the meaning of energy efficient? From Cambridge Dictionary, it means using a little electricity, such as electricity, gas, and etc. It also means to discard things that use only as much as energy as needed without wasting any energy waste. But in engineering terms, energy efficiency is the energy efficient building that can be defined as the building abilities to heat and cool themselves independently. So when we say precast concrete is energy efficient, it means that it has the ability to it has the characteristic to be in thermal insulation. It means that the insulation within the precast wall panels can increase the thermal efficiency and provide continuous insulation within the wall. It also means that the construction will use minimum wood usage, and according to the Canada Department of Energy, cement production is 0.33% of energy consumption, which is lower than steel production and wood production, and we need this in our construction sector in order to reduce the carbon dioxide emissions and also to reduce the global warming. So the effects that precast concrete have is that it allows smaller but more efficient heating, ventilating and air conditioning system. within the house. So this insulation that installed or shaped within the wall panels can increase the thermal efficiency and provide continuous insulation within the wall. So that way it will the energy for air conditioning and also heating can be reduced. Further investigation has tested that precast panel has lower emissions of heat compared to the hollow core wall panel. So the second effect is that the needs of raw materials such as steel and wood can be decreased. So we know that woods are oftenly used for formwork in construction. But the wood usage is not environmentally friendly, and the disadvantage of using wood is that it cannot be reused again after using it, and also it takes time and energy to assemble and reassemble the wooden formwork. Moreover, the more wood we use, the more deforestation activity, which is not good for our planet, and it causes more further global warming and CO2 emissions due to the lack of trees. And then the third effect is that adopting more precast concrete can lead to less carbon emission. It is said that from the precast concrete, the design can help the design can contribute less stress on our environment as the need of raw material is less. So the last but not least, the concrete reabsorbing is up to 40% of the carbon over the structure's life. This will cause adapting more precast concrete can lead as it says that it can lead less carbon emission. And also the design of flat roof or precast concrete slab also help to reflect the heat from the structure. So these are the references that we use for our slides. We hope this slide will be beneficial to those who listen and read, and thank you for listening.